What is up, Math Made Easy fans? Today, we have a banger. This is the problem of the week. This is December 2nd, 2019's problem of the week. Okay? Epic. Now, this is dealing with giving during the holiday season, which is always a good idea. I like to make some donations to charities that I like making donations to. And I encourage you to do that as well. But right now, we're not doing that. We are doing math. So let's get straight to it. A local charity is wrapping holiday gifts for local families in need. When 8 volunteers work together, they can get all of the gifts wrapped and distributed in 6 hours. How many hours would it have taken if there were 12 each working at the same rate? 12 volunteers, okay. So 8 volunteers, 6 hours. Meaning that if we multiplied 8 by 6, each person is doing 1/8 of the work. So if we were to have one person doing all the work, we multiply 8 by 6. That would be 48. Now if we're going to split the work in 12 places, we're going to split 48 hours of work into 12 places. Then that would be 4 hours for each person. Okay. Current class want to adopt a family from the local angel tree. The family that decides to adopt asks for canned foods and a stuffed animal for their young daughter. If each student in the class donates $5, they'll have enough to buy 2 crates of food and will have $1 left over. If each student brings 8, they will have enough to buy 3 crates of canned food and a stuffed animal that costs $11.50. How many students are in the class? Okay. This one can seem a little bit difficult, but I'll walk you guys through this one here at the Math Made Easy Studios. So, if we have 5, we can have 2 canned food plus $1. So, we are going to deal, I hope that it's okay me taking this off, so we're going to need some more space here. So if each student in the class donates $5, well, we have five times the number of students, okay, equals, well, 2 crates of canned fruit. We'll call that 2F plus $1. If each student brings in $8, $3F plus 11.5. Okay? Yes, plus 11.5. Okay, so here we have a system. What do we do when we have a system? Well, we solve that system. Okay? Big brain. But what I like to do when I have a system is I like to put all of the variables on one side. So if I was to subtract these from each of the equations, so subtract 2F and subtract 3F and then put it on the other side, subtract it from both sides basically, we would have 5S minus 2F equals 1. And we would have 8S minus 3F equals 11.5. And I have quite a few videos on my channel actually about solving system of equations. Hopefully you guys know how to do this. And I'll actually let you pause the video right now. Do this for yourself if you want. Okay? Hopefully you pause the video and we've worked out in your head what you think is the solution. We're going to confirm it here at the Math Made Easy Studios. So, let's get going, man. So, how I approach these problems, okay, 2 and 3, I think those are going to be pretty easy to deal with. We can just multiply this by 3, multiply this by 2. I'm going to get 10s minus, we're multiplying, oh my gosh. Oh, we're multiplying this by 3. I literally just said that, did I not? And now I don't do it. Plus 6F equals, well, 3 times 1 is 3. That's not a very pretty 3. 16 of these S's minus, well, that's also 6. That's kind of the point, is to get these 6's kind of the same. Equals, well, this times 2 is 23. Oi, oi, oi. So, now, what do? If you said are we going to add or subtract these? Well, these are the same, so we're going to subtract. So subtract 16 from 15, we get negative S. These, of course, cancel. Negative S equals, well, 3 minus 23 is minus 20. So then just replace these negative signs, and S equals 20. We're getting 20 students in this class. I really like this problem, but let's just check. So if we have 20 students, so 20 students each bring in $5, we will get 2 crates of food. So we have 100 here, and we have something plus 1. So we have 99 plus 1. So 49.50 is what our food is going to be. Now let's plug in this, 49.50 for the food. We're going to have 99 plus 49.50, so 148.50 plus 11.5 is 160. 8 times 20 is 160. We are correct. This is 20. That was a pretty hard problem, not gonna lie, for problem of the week, but you know, the harder the better. That's our philosophy here at the Math Video Studio. So let's do this last little problem. So Greta and Marge are collecting money for a local charity by taking donations outside of busy local businesses. Hoping to collect the most money today, Greta gets to her collection spot and begins collections at 8 a.m. Marge wanted to sleep in, so she didn't start until 11 a.m. I can sympathize with that desire to sleep in right there. By which time Greta had already collected $45. If Greta continues to collect money at $15 an hour, Marge collects money at $20 per hour, and they each take a 1-hour break at 2 p.m. What time will Greta and Marge have collected the same amount of money? So this 1-hour break, I'm just going to omit that and then just add 1 hour to the end. I'll show you how I do it. So we have 3 hours of work by Marge. And then we are starting with no hours of work. 3 hours of work has been already done by Greta by the time Marge starts. Okay? Greta is going at 15 an hour, Marge is getting at 20 per hour. So that means Marge is doing $5 better per hour. But Greta starts $45 better. So how many hours will it take for them to catch up to each other? Well, they're getting $5 closer every hour. So it's going to take 9 hours after this 11 a.m. when Marge starts. So that will lead us to think the answer is 8 p.m., 9 hours after 11. But remember, this 1-hour break just puts us at 9 p.m. And that is the problem of the week. Thank you for watching.